In the remote waters of the South Pacific, roughly 1,200 miles northeast of Australia, an entire island has quietly vanished inside a gray, choking shroud of ash and steam. From high-orbit weather satellites, the archipelago of Vanuatu looks like a string of tranquil emerald beads scattered across the deep blue of the Coral Sea. Palm trees fringe white sand reefs, turquoise lagoons catch the morning sun, and volcanic peaks rise serenely through tropical cloud decks. That serenity is a total illusion, because deep beneath the central caldera of Ambae Island, the colossal shield volcano known as Manaro Voui has violently escalated into a massive new eruptive phase. Here is the part that should stop you cold. When an explosive eruption detonates at Manaro Voui, the shockwaves do not just threaten the local villagers living on the coast of Ambae. The atmospheric pressure pulse and submarine displacement can trigger regional tsunami alerts across the Pacific Basin. Meteorological agencies in Japan and across Oceania have scrambled to monitor sea level anomalies following the sudden atmospheric pressure waves radiating across the ocean. But the true crisis unfolding on Ambae is not just the explosion that already happened. It is what scientists cannot see. Right now, volcanologists monitoring Vanuatu are operating in a state of near total sensory deprivation. The primary ground sensors and summit webcams have been destroyed, buried under tons of corrosive, acidic tephra, or knocked offline by power failures. Heavy tropical clouds and immense sulfur dioxide plumes have blinded optical satellite passes. And the crater lake that once sat at the summit, a body of water holding over 20 million cubic meters of liquid, has completely vanished. Scientists know that billions of cubic meters of pressurized magma are surging upward from the mantle. They know the entire island is deforming. What they do not know, and what the instruments cannot tell them, is whether this is the climax of the eruption or merely the opening clearing blast for an island-destroying phreatomagmatic cataclysm, the anatomy of a drowned monster. To understand why volcanologists consider Manaro Voui one of the most unpredictable hazards on the planet, you have to look at the unique, violent geology of the New Hebrides subduction zone. Most volcanoes on Earth are tall, steep cones built of thick and acidic or rhyolitic lava. When they erupt, they behave according to relatively straightforward physics. Pressure builds, magma rises, and it either oozes out as lava domes or blows apart as a Plinian column. Ambae Island is something completely different. Ambae is not just a mountain. It is the summit tip of a monstrous basaltic shield volcano that rises more than 13,000 feet from the ocean floor. Only the top 4,000 feet break the surface of the Pacific. The rest of this titanic structure is submerged beneath the sea. At the very summit of Ambae sits a massive collapsed caldera containing Lake Voui. For centuries, this crater held 20 million cubic meters of highly acidic mineral-saturated water, the equivalent of 8,000 Olympic-sized swimming pools suspended directly above a subterranean magma chamber. That dynamic creates the most dangerous physical setup in volcanology, phreatomagmatic fragmentation. When superheated basaltic magma at 1200 degrees Celsius rises toward the surface, it does not just erupt into the air. It makes direct contact with millions of tons of trapped water. When liquid water flashes to steam, it expands to 1,700 times its original volume in milliseconds. That violent volumetric expansion acts like a planetary-shaped charge. It shatters the rising molten rock into microscopic, jagged shards of glass and shoots towering ash columns straight into the stratosphere at supersonic speeds. In 2017 and 2018, this exact mechanism forced the complete, mandatory evacuation of Ambae's entire population of 11,000 people, twice. The volcano choked the island in millions of tons of ash, collapsed thousands of homes, and turned thriving tropical farmland into an uninhabitable lunar wasteland. Now, the volcano has roared back to life with a terrifying twist. The crater lake, that once provided a stabilizing water cap, has been boiled away and displaced by rapid tephra accumulation and ascending lava cones. The barrier is gone, and without the weight of that lake, the decompression of the underlying magma chamber has accelerated into overdrive. The sensory blackout, why science is flying blind. When Mount St. Helens or Kilauea ramps up, scientists have access to hundreds of real-time borehole tilt meters, continuous GPS networks, fiber optic strain cables, and redundant multispectral cameras. In the middle of the South Pacific, volcanology becomes a high-stakes guessing game. The Vanuatu Meteorology and Geohazards Department, VMGD, works tirelessly with international monitoring consortiums, but the physical environment on Ambae is actively hostile to technology. 1. Sensor destruction and corrosion. The volcanic plume is venting staggering quantities of sulfur dioxide, surging past 6,000 tons every single day. When that gas combines with tropical humidity, it creates dense, highly concentrated sulfuric acid rain. This acid rain eats through weatherproofing, melts solar panel housings, and shorts out seismic radio relays across the summit rim. 2. Satellite blind spots. While synthetic aperture radar, SAR satellites can penetrate clouds, they only pass over remote South Pacific coordinates on specific orbital cycles. In the critical hours between passes, significant internal structural changes, such as caldera floor inflation, fault slip, or flank collapse, can occur completely undetected. 3. The hydrothermal black box. Because Lake Voui has vanished and been replaced by newly formed cinder cones and tephra piles, the hydrothermal plumbing system beneath the crater is completely unmapped. Scientists cannot see where the groundwater is currently migrating. If seawater suddenly breaches the volcanic edifice and finds its way into the active magma chamber, the eruption will instantly transition from Strombolian fountaining back to catastrophic Phreatomagmatic detonation with 0 seconds of seismic advance warning. The cascading human and environmental disaster. Down on the coasts of Ambae, in villages like Saratamata, Walaha, and Duindui, the human toll is accelerating by the hour. Volcanic ash is not soft like wood ash from a fireplace. Volcanic ash consists of microscopic, razor-sharp shards of volcanic glass, quartz, and pulverized basalt rock coated in toxic chemical salts. Drinking water. Poisoned, Pacific Island communities rely almost exclusively on rainwater harvesting systems from corrugated metal roofs. Heavy ashfall instantly turns collected rainwater into toxic, acidic sludge contaminated with dangerous levels of fluorine and sulfur compounds. Agricultural annihilation. The fine ash coats, breadfruit, taro, and banana crops, blocking photosynthesis and burning the leaves through chemical acid burns. Local food security on the island has collapsed, leaving thousands dependent on emergency maritime relief. Structural pancaking. When tropical downpours hit volcanic ash settled on rooftops, the ash does not wash away. It absorbs the water like cement, decreasing its weight by up to 500%. Residential shelters and school buildings across southern Ambae are facing catastrophic roof collapses. And as the ash continues to fall, the threat of lahars, deadly volcanic mudflows, hangs over every river valley. When tropical rains hit the loose, uncompacted tephra covering the upper slopes of Manaro Voui, the hillsides peel away. Moving walls of wet concrete race down the drainage channels at 40 miles per hour, scouring riverbanks, snapping trees, and severing the only coastal evacuation tracks on the island. The channel call to action, Crust and Storm. If you are beginning to understand why the headlines miss the real story, and why tracking the hidden physics of remote volcanic systems is critical to understanding the stability of our planet, that is why we built this channel. Here at Crust and Storm, we cut through the surface-level news clips to give you the clinical, forensic truth of how the Earth's geological engines operate. Take 2 seconds right now to hit the subscribe button. It costs you nothing, but it ensures you will never miss our deep-dive scientific analyses when the crust beneath our feet begins to shift. The worst-case scenario, the caldera collapse. So what is the ultimate danger that keeps volcanologists awake at night when they look at Manaro Voui? It is the specter of a full-sector collapse and regional tsunami. Ambae Island sits on a region of steep submarine slopes. The western and eastern flanks of the volcano are structurally weakened by centuries of hydrothermal alteration, the exact same chemical process where hot, acidic groundwater rots hard volcanic rock from the inside out, turning solid basalt into soft, waterlogged clay. If a major section of the summit caldera fails and slides down the submarine slope into the deep ocean trench, 2 catastrophic events occur simultaneously. 1. The sudden release of pressure on the underlying magma chamber triggers an ultraviolet explosive decompression event, similar to what occurred at Krakatoa in 1883 or Ha'apai in 2022. 2. The massive displacement of ocean water by the collapsing flank creates a regional tsunami that would strike the neighboring islands of Pentecost, Maiwo, and Espiritu Santo in less than 15 minutes, leaving virtually 0 time for coastal communities to evacuate to higher ground. This is why the current sensory blackout is so dangerous. When a volcano shows this level of persistent unrest, gas surging, and structural lake displacement, every hour of lost telemetry is an hour where an unheralded catastrophe can develop in the dark. The Earth operates on its own clock. Why do human beings continue to build their lives on the slopes of active volcanic calderas? Because the same geological fires that threaten to destroy Ambae are the reason the island exists in the first place. The volcanic ash that falls today will, over centuries, break down into the richest, most mineral-dense agricultural soil on Earth. The subduction zone that fuels Manaro Voui is the very engine that forged the islands of the South Pacific from the ocean floor. Human civilization lives on a temporary conditional lease with the Earth. We build our villages, cultivate our crops, and install our monitoring networks on the calm surface of a living, shifting planetary crust. We expect volcanoes to announce their intentions with neat, predictable patterns that our instruments can translate into clear warnings. Manaro Voui does not care about our instruments. Out in the South Pacific, the plumes of ash continue to billow into the tropical sky. The sulfur gas continues to pour from the fractured summit at 6,000 tons a day, and somewhere miles beneath that blackened, silent island, the magma is still climbing. The volcano has made its opening move. The only question left is what it will decide to do next, and whether anyone will be able to see it before it happens. For incredible drone footage showing the actual scale of these explosive vents and the dramatic terrain changes at the summit, watch Ambae volcano eruption in Vanuatu. This video provides direct visual context of the strombolian fountaining, intense gas output, and fractured caldera floor currently challenging scientists at Manaro Voui.